Hi, welcome to Professional Certifications channel. Let's break down CISSP exam preparation, one topic a day for focused and effective learning. Today's topic is Public Key Infrastructure.
Definition. Public Key Infrastructure, PKI, is a framework that manages the creation, distribution, storage, and revocation of digital certificates and public-private key pairs used in asymmetric encryption. PKI enables secure communications, data integrity, authentication, and non-repudiation in various digital environments by facilitating the trusted use of public key cryptography.
Key concepts.
1. Purpose of PKI. PKI supports asymmetric encryption by providing a structure to issue, distribute, and manage digital certificates that bind public keys to entities, users, devices, or organizations. PKI enables trusted and secure communication between parties who may not have previously exchanged encryption keys. It ensures that users can verify the authenticity of public keys, which are used for encryption, digital signatures, and secure communication.
2. Components of PKI. Certificate Authority (CA). The CA is a trusted entity responsible for issuing and managing digital certificates. It verifies the identity of entities requesting a certificate and signs the certificate with its own private key, creating trust in the public key presented in the certificate. Examples: DigiCert, Let's Encrypt, GlobalSign. Registration Authority (RA). The RA acts as an intermediary between the entity requesting a certificate and the CA. It verifies the identity of the requester and then informs the CA to issue a certificate. The RA does not issue certificates but assists the CA in the validation process. Digital certificates. Digital certificates, also known as X.509 certificates, bind an entity's identity to its public key. Certificates contain information such as the public key, the entity's details, the issuer, CA, the certificate's expiration date, and the digital signature of the CA. Certificates are used in secure communication protocols like TLS, transport layer security, and for digital signatures. Public and private keys. The public key in the certificate is openly distributed and used for encryption or verifying digital signatures. The corresponding private key is kept secret by the entity and is used for decryption or creating digital signatures. Certificate Revocation List (CRL). A list maintained by the CA that contains the serial numbers of certificates that have been revoked before their expiration date. Certificates may be revoked for various reasons, such as a compromise of the private key or a change in organizational status. CRLs are periodically updated and distributed to ensure entities do not trust revoked certificates. Online Certificate Status Protocol (OCSP). OCSP is a protocol used to check the revocation status of a certificate in real time, providing faster and more efficient validation than downloading the entire CRL. Clients contact the OCSP responder, which tells them whether the certificate is still valid or has been revoked.
3. How PKI works. Certificate Issuance. When an entity, such as a user or device, wants to use public key cryptography, it generates a public-private key pair. It then sends a certificate signing request, CSR, to the CA. The CA verifies the entity's identity and issues a digital certificate that includes the public key and other identifying information. Certificate Validation. When a certificate is presented during communication, the recipient can validate the certificate by ensuring that the certificate is signed by a trusted CA, verifying that the certificate is not expired, checking whether the certificate has been revoked by consulting the CRL or using OCSP. Certificate Chain of Trust. The chain of trust begins with a root CA, which is trusted by all parties in a system. The root CA may issue certificates to intermediate CAs, which in turn issue certificates to end users or organizations. Each level in the hierarchy signs the certificates of the level below it, creating a chain of trust. Root certificates are pre-installed in web browsers and operating systems, which trust any certificates issued by these CAs and their intermediaries.
4. Types of digital certificates. Self-signed certificates. These certificates are signed by the entity itself rather than a trusted CA. Self-signed certificates can be used internally within an organization but are not trusted by external users or systems because they lack the verification process of a trusted CA. Domain validation (DV) certificates. Issued after verifying that the certificate requester owns or controls the domain. These certificates provide a basic level of assurance. Used in websites to establish encrypted HTTPS connections. Organization validation (OV) certificates. Require more thorough identity verification than DV certificates, confirming the legitimacy of the organization requesting the certificate. Use for securing websites, emails, and some applications. Extended validation (EV) certificates. Provide the highest level of trust by requiring extensive identity verification. EV certificates trigger visual indicators in web browsers, for example, green address bar, to assure users of the legitimacy of the website. Often used by financial institutions and e-commerce websites. Wildcard certificates. Allow a certificate to secure a domain and all of its subdomains. For example, a wildcard certificate for star.example.com would cover www.example.com, mail.example.com, and blog.example.com. Code signing certificates. Used to verify the integrity and authenticity of software or code distributed over the Internet. Code signing ensures that the software has not been altered or tampered with since it was signed by the developer. Email certificates, S/MIME. These certificates are used for securing email communications. They enable email encryption and allow for digital signatures to verify the authenticity of the sender.
5. PKI Use Cases. Web security, HTTPS PKI is essential for securing websites via HTTPS by issuing certificates to websites that enable TLS encryption. When you visit a secure website, the browser validates the website's digital certificate to establish trust. Secure email, S/MIME PKI allows users to send encrypted and signed emails. S/MIME, secure/multipurpose Internet mail extensions, relies on digital certificates to authenticate the sender and ensure message confidentiality. VPNs and secure networks. VPNs use PKI to authenticate users and devices attempting to connect to a network. Digital certificates validate the identity of users or devices, allowing them to establish a secure, encrypted tunnel for communication. Code signing. Developers use code signing certificates to digitally sign software and applications. This ensures that the code has not been modified and verifies the identity of the developer or organization. Digital signatures. PKI is the backbone for creating digital signatures, which are used to verify the identity of the sender and ensure the integrity of messages or documents in financial transactions, legal agreements, and secure communications.
6. Security considerations in PKI. Private key protection. The security of PKI depends on keeping the private key secure. If a private key is compromised, an attacker can impersonate the key's owner or decrypt sensitive data. Certificate expiration and revocation. Certificates have expiration dates to limit their validity. If a private key is compromised or if an organization no longer requires a certificate, it must be revoked, and the revocation must be communicated via CRL or OCSP. Trust issues. If a trusted CA is compromised or issues fraudulent certificates, the entire trust chain is broken. This has happened in the past when CAs were hacked or incorrectly issued certificates.
Importance in the CISSP exam. PKI is a significant topic in the security engineering and communications and network security domains of the CISSP exam. CISSP aspirants need to understand how PKI supports encryption, digital signatures, and authentication. The exam may test knowledge of the components of PKI, CAs, certificates, key pairs, how certificates are issued and validated, and the role of PKI in secure communication protocols like HTTPS and S/MIME. PKI's integration into cybersecurity infrastructure is key for protecting data and communications.
Real-world example. When you visit a secure website, for example, a bank's site, your browser checks the website's digital certificate. This certificate, issued by a trusted CA, contains the public key of the website and proves its identity. Your browser uses this public key to establish an encrypted TLS connection, ensuring that the data exchange between you and the website is secure and private.